Okay, a quick introduction video which describes the new Amesh 2.4 gig single radio mesh unit. Okay, so anybody who's looked at any of my mesh videos before probably knows I'm quite a big fan of the mesh units. I think it's an ideal way to give blanket Wi-Fi for outdoor configurations like caravan parks and that sort of thing with a minimum of fuss. So what a mesh unit or a mesh network consists of is a whole series of repeating nodes. These are radio nodes which intelligently repeat the traffic between them. As I say, it's intelligent routing. So if you have a whole series of repeating nodes covering a site, what happens is they work out the best way to route the traffic from A to B depending upon which nodes they have to go through. Because the routing is dynamic and can be reconfigured automatically, there is a high degree of redundancy and self-healing. So if any node goes down or traffic congestion increases at a node, the systems will automatically find the next best route and start using that. Key thing about a mesh system is it only routes the traffic through those nodes which are actually required to route the traffic. Now, this is different from quite a few normal repeating setups where traffic goes in one end and all of a sudden all the nodes are repeating whether they need to or not. The thing about a mesh is only those nodes involved actually handle the traffic. The other thing about the routing protocol is it's loop free, so it automatically squashes any chances of the actual traffic looping back, and they're self-starting. It all comes down to the fact that they're automatically start with the configuration, automatically learn the routing. The other thing about a mesh system is it can have multiple gateways. A gateway is basically where the internet comes in. So if this is used for sharing the internet over a caravan site, you could actually have internet access coming at multiple sources. Typical applications for meshing. Well, anywhere where you want blanket Wi-Fi but with high resilience. For example, caravan sites, villages or communities, holiday parks, marinas, etc., etc. Now let's go through the characteristics of mesh nodes. The most popular type of mesh unit is what is called a single radio. So it has one radio interface inside, and that radio interface is used for both the client connectivity and for the backbone connectivity. So typically this would be a 2.4 gig radio card inside, and the 2.4 gig radio card is doing both jobs. The advantage of a single radio mesh is they're cheap. There's not much to them. All they are really are very good outdoor units, but with special software running on them. Dead easy to set up. You haven't got any complicated things like playing around with the different radio settings for the two nodes, for the two interfaces, sorry. And very simple physical installation. You haven't got to worry about multiple antennas or that sort of thing. You just bang it up with its single antenna. Bad points. Well, because you've got the single radio which is doing both the local traffic and the backbone traffic, you can end up with a conflict of interest. So if a node has a lot of client connectivity at one particular point, then it's not going to have much bandwidth left over for routing the backbone traffic. But in a proper mesh, the mesh network should automatically appreciate the fact that one node is not very good at routing the backbone traffic due to high load, and actually start preferentially routing the traffic through other nodes which are less busy. The other thing about a single radio mesh setup is almost certainly it's going to end up being 2.4 gig, because that's the Wi-Fi that everybody uses, in which case you can end up with congestion interference with other Wi-Fi networks in the neighborhood, and also actually within itself you could actually get network interference or congestion, Wi-Fi congestion between the actual nodes. But that can be tuned out and minimized by obviously carefully adjusting the RF output power of the units. Dual radio, well, what that has is that's a mesh node with two radio interfaces in it. Typically you have one radio which is doing the 2.4 gig local connectivity, and you have another radio node which is doing the backbone connectivity. Now because you've got two radio interfaces doing the job, then obviously you can get better performance down that backbone because there's only one radio dedicated to the job. If you're using a 5 gig backbone, that's even better, because obviously that way you don't run the risk of any of that 2.4 gig rubbish interference affecting the backbone linking. Bad points, well, they're expensive, typically 5 or 6 times the price of a single radio node, and also they are more complicated with the setup because you've got more than one radio interface to play with, so it gets a little bit more fiddly setting them up. Now let's go through the new Amesh product. It's the Amesh 100, the purpose of this video. Nice little cute white plastic box thing. It's a 2.4 gig radio, single radio, so it uses the same 2.4 gig radio for the client connectivity and for the backbone. It's a layer 2 mesh. I like layer 2 meshes because the whole network all appears as one IP subnet. No complicated things with different IP ranges on different nodes. It's all the same network. Now the Amesh unit uses time division duplex for backbone traffic. What that basically means is it automatically works out the proportion of bandwidth that it needs to devote to uplink versus downlink traffic. And this is dynamic, so it's all the time monitoring how much of its time or how much of its bandwidth it needs to allocate to the particular route the traffic is taking. This means it's got greater flexibility with variations on data loads and types. So as the load on the network changes, the system automatically alters the proportion of its bandwidth dedicated to the particular route of the traffic. The thing about the Amesh, another thing about the Amesh, is it's got bandwidth control for the access point client connections. So what that means is you can actually tell it to actually limit the client bandwidth. That's quite useful because obviously you don't want the situation where some clients are grabbing a higher proportion of the bandwidth than others. Now the thing about this is you can actually limit it down, so you can limit it to 0.5 meg or 200k or something like that. So all the clients get a fair crack of the whip. The Amesh system also comes with a fairly basic but fairly useful Windows Mesh Manager software, which allows you to do simple setting up and configuration, but also more usefully gives you overviews of the links, routes and the qualities of those links. Allows separate security for the AP and backbone, so you can have WPA security or whatever for the actual AP connectivity and different security running for the backbone. Not necessarily personally a big fan of Wi-Fi security of mesh systems. My opinion is it just makes it more complicated for the end user because they have to start worrying about passwords and all that sort of thing. Whereas I think a better approach is actually to do user management. That's where you actually have a hotspot controller sitting on the network, and what that does is it actually directly controls the user connectivity and their logging on, etc. The Amesh includes WMM for both the AP connectivity and the Meshlink connectivity, so that should give automatic prioritization for multimedia traffic. Has a facility to do a periodic reboot, so you can actually get it to actually do a clean slate restart on a regular basis, for example every 12 hours or every week or something like that. You can adjust the RF power, and you can individually set the RF power both for the AP and the mesh connectivity. This is quite useful to actually try and reduce the cross-node interference between the nodes on any mesh network. You don't want the meshes broadcasting all over the site. All they need to do is basically give the local connectivity up as far as its mesh clients or its mesh neighbours. And the other thing about it is obviously it's PoE, so the Amesh supports standard 48 volt passive PoE power. So what we'll do now is we'll just go through a video describing the hardware of the Amesh system. Okay, so let's just look at the hardware of the new Amesh 100 product. We'll just get it out of its cardboard box. Now the first thing we've got in here is we've got a CD which has the software and user guide on it. Get that out of the way. We have internal LAN cable which goes from the PoE adapter to your internal network. Shut that down. We have a Jubilee clip, and the Jubilee clip attaches to the bracket on the back of the Amesh and fixes it to a normal pole. Got the PoE adapter itself, So this takes the mains power and your network in and sends network and data back out again up to the AMesh unit. And here we have the mains lead for the AMesh PoE adapter. Okay, let's get this out of the box. This is the actual AMesh unit. Just put this to one side for the time being. And finally, about the box, we've got an outdoor waterproof RJ45 cable, which has a waterproof RJ45 connector on the end. And this is to take the power and data from the PoE device up to the AMesh product. So let's get rid of that. Okay. Now the AMesh unit itself, as you can see, it's rather a neat plastic housing, metal backplate which is fully sealed all round. It's a very waterproof piece of kit. On the bottom here we have the waterproof RJ45 connector, which is where the data and power goes in. And on the top, if I can get this off, at the top we've got the obligatory end socket for antenna connectivity. Looking at the back again, what we've got on the back is we've got a mounting bracket. That's where that Jubilee clip goes for pole fixing. And on the bottom here we've got indicator LEDs which just give you wireless status, LAN status, and whether the power's on or off. So the whole thing is well sealed all round, and that's the AMesh unit. Thank you very much. Okay, so that's the hardware of the AMesh product. Now what I could do is we'll just go through the software side of it. So we'll just actually go through what the various screens are and also introduce the Mesh Manager software. Okay, let's look at some of the configuration screens on the AMesh product. We'll just go to its web page, which is 192.168.1.100. Enter. Admin. Admin. Enter. Okay, let's see what we've got here. Okay, it starts up on the system page. We've only got 5 menu items across the top. Info, which just gives you the basic information about the firmware version, etc. You've got system here, which gives you features like, for example, here you can actually change the host name, so this is what identifies it on the mesh network. You can set up a periodic reboot. This is so you've got a clean slate. So, for example, you could say, I don't know, reboot every night, for example, so you can set it for 1 day or 2 months or whatever. You've got the usual NTP settings here, so you can put in server names and that sort of thing. If you've got a password, you've got the usual thing for changing the administration configuration password. Backup and restore, obviously just back up this configuration or reload a configuration or set to defaults. We've got firmware upgrade, and we've got reboot, so you can actually reboot the unit after doing a configuration change. Now the main menu item is network. This is the one that does all the business. So you've got 2 networks. You've got the LAN side. So here is just the setting for the LAN side, which has to say is default 1.100. And here you can add in DNS servers. And we just click on wireless. Now under wireless, at the top you've got the generic settings. So this is the operation mode. Now most of the times you'll use this as an AP with a mesh. So it's got a mesh backbone with a local AP coverage for local clients. The other options are it can be an AP only, or it can AP plus a station. So it can actually be a client, so it could actually connect to another AP. So you could have this set up as a point-to-point link or something like that. Usual things for setting what Wi-Fi you want to use, FCC or ETC for channel selection, normal channel modes, and a distance parameter, and you set that to roughly the longest distance of the links that you got. Now these are the 3 main sections for the wireless configuration modes. You've got the access point setup. So do you want WMM switched on? Do you want to control the transfer rate, transmit power, RTS settings, fragmentation threshold, SSID, etc., etc. Also, this is an interesting parameter. It's actually got a bandwidth control. What this actually does is it controls the maximum bandwidth associated or applied to each particular client. So for example, if this is set up as 1 meg, even if a client actually has a 54 meg Wi-Fi link, the maximum traffic speed that they can attain is limited to 1 meg. And this can actually go right down to 200k or up to 2 meg, or it can be disabled. With disabled, they can grab as much as they can get. A useful feature in a mesh environment where you may actually want to limit the specific download rate of individual clients. Usual wireless security for all of the client AP connectivity side. Now this is the actual wireless setup for the mesh side. So here you have, yet again, do you want to actually put WMM enabled or disabled on the mesh backbone? Same things again for transmit rate and transmit power, and the same things for RTS, fragmentation threshold. Here we have the mesh ID. When you're setting this up, all units that have the same mesh SSID on the same channel will try to connect to each other. If the mesh SSID is different, then it won't connect to this particular mesh. So it means you can actually run 2 meshes close to each other without them interfering with each other. And you can also put a AES encryption on the mesh backbone. You've got to remember that the Wi-Fi for the mesh backbone cannot generally be picked up by any wireless client. Certainly when we've tried it here, we couldn't find anything that could see it. We couldn't find a Windows notebook that could see it. We couldn't find any Wi-Fi phones that could see it. So it's effectively a completely hidden Wi-Fi network that links the mesh units together. Station side is when you actually want to set it up as a client, so it can connect to a neighbouring access point. Other main menu item here, we've got status. Gives you all the usual stuff about volume usage, number of connections, etc., etc. You've got interfaces here. It gives you stats upon the various interfaces being used by the device. Perfectly frank, I don't understand 1/10 of what all this means. So as long as I'm concerned, as long as it works, what the hell. ARP figures, netstat figures. You know, as if I really understand all this, not. You can do some basic diagnostics like some ping tests and that sort of thing. The mesh side actually gives you figures for links to neighbouring nodes. You notice this device actually can see 3 neighbouring nodes with different RSSI figures. Basically, anything over 42 is good. You know, that's worth having. If it gets less than 42, then the links are starting to get a bit poor. No clients associated to the AP side. Station configure status doesn't tell us anything at all because it's not set up as a client. And site survey doesn't work either because, yet again, that applies to it actually being a client. Come on, computer, you could do it. Right, let's just go look at the log now. Log function is so you can set up a syslog server to receive various logs, give you the information. Now it's all written down here what these various types of information are. To be honest, I've never used them. This product just works, so I don't need to play around with that sort of thing. And that's it. That's the basic configuration screens of the Amesh unit. Okay, so that shows the basic software configuration screens of the Amesh product, which you can access through its web interface. Now, the other thing that comes with this product is a simple Windows mesh management software utility. What this does is it allows you to discover the nodes on the network. When you have the actual nodes displayed, as you can see there in this little picture on the right hand side, you can edit the key parameters of the mesh nodes, for example the mesh ID, the SSID from the AP interface, etc., etc., and you can change the configuration either individually or globally. It will also give you link strength, so you can actually see what the link strength capabilities are between the nodes. Basically, anything beyond about mid-30s is a good link. Anything below mid-30s that you need to think about restructuring. You can also draw you a nice quick pictorial map of that same link strength information. It's a very basic map, to be honest, but it does give you a quick visual indication of what the link strengths are between the actual nodes. So if we think about a simple example of using the A mesh unit, I've drawn a rough picture here. You can basically see we've got 4 mesh units. Now the aim here is that all the mesh units will automatically connect to another, and what you need to do is arrange the mesh units around the site so as to give the best client connectivity and of course the best backbone connectivity. Now usually it's the client connectivity which is the hard part. You need to ensure that every client that you want to connect to the mesh can actually see a mesh node. And by see, I mean see. I don't mean behind the side of a caravan, behind the toilet block, or through a hill. They actually need to be able to see where the mesh node is. The key thing about Wi-Fi is it's the same as all radio. It's essentially a line of sight medium. It doesn't like going through objects in the way. It'll try and reflect and bounce off to try and get round objects, but really if you want a reliable system you need to be able to actually see and to connect to the units. Now the thing about the A mesh unit is it will support both local Wi-Fi clients connectivity and connectivity through the LAN port. The other thing about it is any node can be the gateway. As far as this mesh unit is concerned, it makes no distinction as to which node actually has the internet connectivity. It doesn't care. All it's doing is routing traffic from point A to point B based upon MAC address routing. So what happens is if a client or a desktop, for example computer, wants to actually connect back to the internet, it knows the IP address of the default gateway, so the first thing it does is it gets the MAC address of that and then asks the mesh unit to actually, or the mesh unit automatically routes out the best way to route that traffic to that particular MAC address. It's all done in the background by the mesh unit. As far as the clients are concerned, they're just doing a normal Wi-Fi connection. And the example on the right hand side shows the internet source actually going through a WAS 105. This is a AAA device, which basically means it's got user management and user control. So it allows you to actually control the network on a user basis. So you can set up username, passwords, charge for it, and do various usage limitations. Okay, what we're going to do now is do a quick video which actually shows how to actually do a simple setup of a 4-node A mesh system. So that's pretty much along the lines of the example that we've just shown you on the screen. Okay, let's show a simple configuration and setup for the A mesh unit. Now, the easiest way to do this, in my opinion, is to use the actual Mesh AP Manager software that comes on the CD with it. So here I've put the CD into the drive and the initial startup menus come. So this is the installation menu, so we just click on this button here. And hopefully what it will do is it'll go ahead and usual thing for installing the etc, etc. I won't continue with this. You know what it's like installing software. You just continue blah 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 start and it will install it. So we'll just exit that. I should have exit this. Get out of here. Get out of here. Now once it's installed you end up with an icon on your desktop and we'll just double click on it now. Now what I've done is I've connected one unit to the actual network here, and here you can see it's been discovered almost instantly. MAC address, host name. Don't remember, but I did actually mention that in the other video where you could actually change the host name of how the device appears on the network. Its IP address, mesh ID or SSID. Basically, this has to be the same for all the units to mesh with each other. The AP SSID, this is what the clients see when they try to connect with their notebooks, etc. Channel, operation mode, etc. And here you can see the alterable settings for this actual mesh node. So these things we can't change from this screen, but we can change the mesh ID, the AP SSID, the mesh key. That's the encryption key used for the backbone connectivity, the operation mode, and the channel. And we can do change, or if we have multiple devices here, we can actually select multiple devices, do a single parameter, and then do change all, and it will change all the parameters for us. But let's just show what we can do about trying to set up this particular unit now. So if we actually double click on the item, it brings up just straight to a web interface, admin for entering it. Okay, so we'll just look at the parameters that you would normally consider altering when you actually want to set up a bunch of devices. Let's say you've got 4 units and you want to set them up auto-meshed with each other. Now this is very, very quick and easy. There's not much that you'd actually need to change to get a basic system going. So the first thing is you'd probably want to go to network. Now the first thing is you probably want to change the IP address. If you're going to have several of these all on the same network, you want each of them to have a unique IP address. So I'll just give this, I don't know, 101 so it doesn't clash with anything else on the mesh network. So 100 is the default address. So what we'll do is we'll have units at 101 and then we'll pick unique addresses for the other ones. You do save changes. After you've saved the changes, after you've done all your saving changes, what you must do is you must do save flash. What that does, it stores the configuration to the flash, and what you have to do after you've done that is you must reboot. So click on status, sorry, wrong menu item, system, and then we click on reboot. Do you want to reboot? Yes, we do. Now when it's done, it's reboot, and it will take approximately 80 seconds for it to come back again. Okay, we've waited approximately 80 seconds, so let's just see what happens now. Now obviously it's now no longer finding the unit on address 100, or the browser's not finding the unit on address 100, so we'll go to 101, and there it is on 101, admin, default username password, and we're back into the continue configuration of the A-mesh. Go back to network again. So we've changed the address to 101. That's the first thing you probably want to do, just change the LAN address. And the other thing that you might want to do is if you go to the network wireless settings. Now the default is AP mesh mode, so you want to check the channel. You probably want to change this to ETSI for UK EU operation. Make it a bit bigger so we can see what's going on. Now, under the AP mode, remember this is what the clients see. So this is the actual access point that the clients will see. Transmit rate, I suppose normally you want to leave that for auto, so it tries to go as fast as it can. Transmit power. Now this is an interesting one. Obviously the temptation is to whack it up to full blast, but be careful. You're going to cause interference with other units, etc., etc. So try and be sensible with the power. Probably start off maybe at 20, but after you've got it all working, see if you can actually reduce the power and still maintain decent connectivity for your clients. This is the SSID that the AP presents itself as. Now you could actually have the same SSID for the access point side on all of the mesh nodes. So as far as the client's concerned, they see them all as the same SSID, or you can give each one individually an individual SSID, so you can have, I don't know, SSID by the toilet block or SSID by the clubhouse or something like that. Then you've got the bandwidth control. Now the default normally is this is disabled, so the clients can grab as much bandwidth as the system can dish out. But if you want, what you could do is you could actually limit this to actually control back what the clients can actually use. Probably a good idea, specifically if this is a caravan site installation or something like that. And let's face it, how much bandwidth do they need just for checking their emails and looking at their eBay bids? So maybe you want to knock this down to even 200k. Encryption type. This is the encryption that the clients have to do when connecting to the access point. Personally, in a distributed network, mesh network, if it's a caravan site or holiday park or something like that, I'm not a big fan of having encryption on the client connectivity. What you should really do if you want to control the clients or the users is actually have a user management system actually at the back end, so that actually controls what the users can do and access as far as the internet is concerned. But if you want, you can actually put security on the individual link, but obviously if you set security, then you're going to have to tell all your clients what the security is, etc. This is the mesh setup side. Obviously got the transmit rate. Normally you'd have this set to auto, so it tries to go as fast as it can. Yet again, you've got this transmit power. Notice you've got individual transmit power for the mesh than you have for the AP. Yet again, Be sensible with this. Try and set the transmit power so that the mesh can see its immediate neighbours, but generally no further. Seeing further just causes further interference for the rest of the mesh. All we want to do is see your immediate neighbours. So yet again, start off with maybe 20 dBm, but maybe actually start reducing it depending upon how the mesh configuration performs. Mesh SSID or Mesh ID, this is the ID that all the mesh nodes must have in order for them to link together. So if you've got 4 mesh nodes, you want them to all be on the same mesh. They all must have the same Mesh ID. As I explained in the other video, by playing around with this, you can actually have 2 meshes in close proximity, or 2 meshes even operating over the same area if you want. As long as they've got a different ID and a different channel, then they should be able to work side by side without any interference. You've got an encryption. This is the encryption that's actually set up on the mesh backbone, so the data actually going between the nodes can be encrypted. I suppose you could set this to AES and put a figure in there, but yet again, I don't think it's super important that you do that, but it's there if you want to do it. And you've got the station mode. So the only thing that you're probably going to want to do to get the actual mesh up and going is just select your channel, select the channel domain, leave everything else on default. So all you have to do is the channel domain for Etsy and set a channel. Wireless distance is set by default 300 meters. To get the basic thing working, leave it at 300 meters. You can go back and tune it later on to what the actual distances are to the immediate neighbors. So once you've done all that, all you have to do is the same thing again. Save changes. Eventually, once you save the changes, just like before, you have to save the changes to flash. So save flash, and once you save them to flash, what you have to do is reboot the unit. So we'll just wait for that to finish. Okay, and yet again, system, reboot. And click on yes, reboot now. So now that it's rebooting, another 80 seconds, it should be ready to go again. Okay, so we had 80 seconds, and now what we have to do is we have to retype in the address to get into the unit. Obviously 101 now. Just booting up. So that's it. That's basically the configuration that we need to do. So if you've got a bunch of mesh units, let's say at 4, all you need to go into each one is go to the network. Make sure they've got a unique IP address so they don't clash with each other on the network. Go to wireless. Change the country domain to Etsy. Choose a suitable channel. And if you want, you could change the AP SSID and the Mesh ID. That's the basic configuration. That's all you have to do to this piece of kit. Now if we go back to the AP Manager, we'll just click on Discover again. So it's now found this new mesh node. So what I'm going to do now is I'm going to rush off and do 3 more nodes, and then we should have 4 all showing here, and we can see what features like the map does on this actual AP Manager. Okay, so now I've done all 4 mesh units, and on the AP Manager I've just done Discover, and here are the 4 that it's found. This is the original 101, which I've now put back on the network. So 101 is where the network comes in, and the 201, 200 and 202 are the outlying mesh nodes. And what I've done to all of these units when I've set them up is I've just reduced the transmit power to 10 dBm. This is because I'm using them in the office, and if you have high output power, then you just end up interfering with each other and slowing down performance. Now if we take each node in turn, what we have here is a list of its neighbours, and basically you're really after signals that are sort of greater than halfway. This is 38. Obviously greater than 40 odd gives you an excellent signal, but really anything more than sort of the good region means you're going to get decent connectivity between the nodes. What we can do here now on this screen is here we have auto refresh. What that does is it just keeps it rediscovering all the time. And what we can do is we can click on map. Now map actually shows the links between the units, and you've got different coloured lines for indicating the quality of the links. So you can see that we've got all the units identified by the MAC address. So we've got 4C, that's 4C. And as you see there, if you hover over it, it just replicates the information here that's actually shown over here. So you've got 4C, you've got 40, you've got 22, and you've got CC. That's these nodes here. Now you can see that the link between 22 and CC is only a good link. Now if we click on, let's exit back out of this and go to 22, then click on, right, so that's actually showing us the link. And as you can see, yes, indeed, the link between 22 and CC is actually starting to move out of excellent into good. So that was showing us the yellow quality of the link. Go back to that map again. There you can see it. 22 to CC is only a yellow. That's a good quality link. Obviously what you're after is excellent quality links all over the place. So we could come out of that. The other thing which I probably mentioned before is you could, if you want, alter the mesh key. That's the AES encryption that's actually used for the backbone link. Now this column here shows whether there's actually an encryption set or not. At the moment there's no encryption set for any of the devices. Now other things that we can change. Now notice, for example, that what I've done is I've set these new units up on their own AP SSID. But if I wanted to change this one, let's say I wanted to change it back to generic. I just do that. I click on change. Are you sure? And what it'll do now is it'll go and change this device. Now, although it's actually showing it changed here, what's actually happening in the background now is this unit is actually rebooting. So that unit's rebooting, so it won't actually be on the network. So although it's shown on here, you won't actually be able to connect to it at the moment. But usually within about 1.5 minutes, that will actually be live, ready for connectivity again. That's basically it. That shows how it is so simple to actually configure and use these units. Yeah, you can use the AP manager to actually bring them up, jump from the AP manager to the individual configuration. So the main thing you're going to need to change is probably just the IP address of the device, and a couple of tweaks actually on the wireless configuration. Once you've got it all basically working, then you can go back and start playing around with some of the more adventurous parameters. Like you might want to go start playing around with the security, maybe, bandwidth control, maybe, etc., etc. But don't start playing around with all these toys until you've got it basically working. Until you can see all the devices coming up meshed on your AP manager, don't bother playing around with things. Get this bit working first of all. And that's it. That's how to set up the AMesh unit. As far as I'm concerned, it's the simplest, easiest mesh unit I've ever played with. Okay, so that's the end of that then. Just a quick series of videos which actually show you about the new AMesh product. As you can see from what we've been through, I think the product's damn good. I've been you know what I mean. Getting quite excited about it. I think it's an extremely good mesh product. Of all the mesh systems I've ever played with, it's certainly got to be the easiest and most simple to set up. Which is an important factor because a lot of these mesh units are very intelligent and they can do lots of fancy stuff, but if it's just too hard for the users to configure and get working in the first place, then it's a bit of a waste of time. The thing about the AMesh unit is it's an absolute piece of doddle to set up. It really is easy. I've probably strung it out a bit in this video, labouring some of the points about it, but honestly, when you actually get the units there and try to set them up, it really is a piece of doddle. You can set up a simple mesh network in literally minutes. It's very, very quick. Anyway, that's the AMesh product. It's on our website, so buy some.